Welcome back, I'm Chris Moore with HVAC Pro Blog, and this month I'm excited to share a training that I actually performed approximately 1 year ago for my Patreon members. Over here on Patreon, you're actually able to get all of this content up to 1 year early. So this month, it's about a 30-minute training that we're actually going to talk about air testing and balancing. We're going to do an overview of ACA Manual B, and I'm going to discuss the documents needed in order to perform air testing and balancing, how to measure CFM, installation issues, a couple things that testing and balancing cannot fix, testing airflow at registers and diffusers, and an overview of the 3 most popular methods of air balancing. So let's get to it. First off, the manual walks you through all the documentation that's needed, and really what they harp on is you can't test and balance a system until you have designed and installed the system, right? So this sounds elementary, but it's the chicken and the egg, right? If you're out there and a code inspector requires a testing and balancing, then if you did not design the system correctly, the testing and balancing is not going to help you. You can't just go and T&B the system and expect it to be right. So first off, what you're going to need is the duct design documents, and that's typically your duct sizing worksheet because it's going to give you dimensions of the ductwork and the CFM values that you design to for those spaces. So also keep in mind here, that is the 3rd step of proper residential system design. You got to do the load calculation room by room first, then you select the right size piece of equipment, then you design the ductwork. Then obviously you install and test and balance it, right? So dimensions and CFM are important. Obviously you're gonna need the location of balancing dampers. If you're not the person that designed it, you need to make sure you pass this along to whoever's doing the T&B for you. Also, you need to make sure that you have the design airflow that is needed for the space that you installed for any sort of fresh or outside or makeup air. So that is really important. If you don't have a balanced space, they need to know that there is negative pressure exhaust systems, there are positive pressure exhaust systems. So we need to know in the design so that way when you test and balance it, everything is running correctly, okay? So that's just the front piece, the ductwork. Obviously you're testing and balancing ductwork, but in order to do that, you need to know what it should be operating at. So you're gonna need equipment specs. That means blower performance. So typically if you have a PSC or X13, non-variable speed ECM motor, you'll have curves like this. So based on your static pressure, it gives you a certain volume of air. Obviously, you want to set that volume of air to your design, all right? We're actually within 110% of your design. Then you're going to want to know the pressure drop that's designed for any other device that you added to the system. So you need the pressure drop chart for the coils, the filters, registers, diffusers, anything that the air passes through that is not within the box that's shipped with the blower. So you don't need the pressure drop of a heat exchanger within the furnace because the blower is shipped with the heat exchanger. But if you're adding a hydronic coil to an air handler, you would need that. Or if you slide in a toaster, right? The electric resistance heaters that go inside a heat pump a lot of times, you'll need to know the pressure drop of that because it's not shipped with the blower, okay? So really important. Any other component that you add that goes on your friction rate worksheet in Manual D that has a pressure drop, you want documentation to know what the pressure drop is going to be, so that way we know that it's running at design before we test and balance the system. Now, you need to know how much volume of air is actually running. So when we make that setting, sometimes we're exact. Actually, variable speed ECMs are typically really close to our settings. Sometimes it's not exact. So we need to know what the volume of air actually is. And there's 5 approved methods through the ACA QI spec, the quality installation spec, that you can use to test airflow, volume of air, as total CFM. The first method, which is not usually used, is called Duct Blaster pressure matching. A lot of times when you hook up your Duct Blaster to measure the leakage of the duct system, you can also disconnect all the not disconnect, but take all the supply register coverings off after you're done and turn the duct blaster back on and match the static pressure that's typically in the supply duct. And then you'll know how much volume of air is passing through that duct blaster. So that's measuring the volume of air, all right? you would turn the system on, and because of the restriction, turn the Duct Blaster back up to match it. So that is one method. I would not recommend running out and buying a Duct Blaster to measure airflow. That's very expensive and very time consuming. There are a lot of much easier methods, all right? One of the least expensive, but not the most accurate methods is using a hot wire or mini vane anemometer and doing a duct traverse. So you would do this typically away from, any sort of sharp bend, actually 4 dimensions away from a sharp bend, just like your duct design. And you're gonna actually put evenly spaced holes across, let's say, that rectangle or circular duct to measure the total volume of air before any takeoffs. So that one, unfortunately, if you turn your wrist slightly, you could get a completely different feet per minute. So there is a lot of math in that. You'd have to get an average feet per minute and then convert that to cubic feet per minute to get CFM. So that is approved, which is why I'm mentioning it. Also not very accurate. Every time I did this, I always ended up with a different number, and never mind repeatable for somebody else. So they have a different way of holding that as well. So highly recommend some of the next couple methods here. The one that I liked the most, that was the most repeatable, that didn't rely on any charts, was the true flow plate or a flow grid. And that slides into the return of your air handler, so where the filter slot is. And you'll notice the gasketed sides. There's 2 different sizes, and they come up with blanks to make different size filters. Obviously, the holes will face into the airflow in the return, and it gives you basically a duct traverse for you. It's measuring pressure, and you would convert pressure to CFM, or if you have their meter, you can read out CFM. It's so fast and easy, and every time I slid that in, I got the same number, and the person next to me would get the same number all the way through when we were teaching these. So highly recommend a true flow plate. It's a little expensive, but very, very useful, because you could be out there on a service call measuring airflow. Obviously, we're talking about testing and balancing new systems here today, but that doesn't mean you don't recommission existing systems. If you don't have all the paperwork, don't get me wrong, there's a lot of stuff available on Google, but if you can't find it, this will still give you volume of air. I would say the least expensive method, and the one most often used because you have a blower chart, is manometer pressure drop. And typically you're gonna measure external static pressure outside of the box shipped with the blower. So that diagram I just popped up on your screen here, you can see we would measure in locations 3 and 1. So 3 in the return for negative pressure, 1 in the supply. You add the 2 together, remember it's differential. So if you measured negative 0.3 in the return and positive 0.3 in the supply, that would be a total external static pressure of 0.6. So if you did not replace the filter that was shipped with the unit, you could measure in location number 4, but most people replace or add on filters that are better, especially these days. So you'd have to measure after that filter, right before the blower. So if I was to add, let's say, electric resistance heater to this, I would be supposed to measure prior to that electric resistance heater, or a hydro coil in the supply, or anything else I'm adding that would add pressure drop to that box, all right? So you have to measure in the right spots. And then the last one, which can be used for heating equipment only. So a heat pump with electric resistance, a gas furnace, oil furnace, propane, right? So you actually can measure temperature rise, clock the gas meter, know what the how much BTUs per therm is being delivered to your space. Obviously, that's going to vary based on your location in the United States. And then you'd be able to calculate, using temperature rise, the actual heating BTU output, and then pull your CFM out of that. So it is another method. It's probably not the best, but at least you'd have calibrated, thermometers, and you could measure it and know. I used to do this a lot on electric resistance air handlers, really for heat pumps. I'd kick those electric heaters on, measure the amperage, know what my total BTUs were, and pull the airflow out of it that way. A lot of times when I was doing, maintenances in the spring on a heat pump, I could kick those heaters on in the morning and measure volume of air. It was a really quick, easy method. So highly recommend it. The most popular method, though, is probably using a manometer with pressure drop. So we need to first, when we do a test and balance, measure the total CFM of the equipment. So that means if you have a zoning system, all of the zones are wide open, bypass dampers are shut down, and we're running at 100% or maximum 110% of airflow, all right? Interior doors should all be tested with the doors open first, all right? And then you close the doors. So really, really important. Make sure that those doors are open and you have all of those return paths wide open. Now, if the system was not designed correctly and you did not have a return in every bedroom, you're going to see pressure differences and it's going to affect airflow. So you could have a higher return static pressure because you're pulling all of your air from a hallway, which obviously doesn't meet code, but they're out there. And if you're doing a retrofit, this could impact volume of air. So very important you test it both ways. Start with all the interior doors open. And then of course, your airflow has to be at max speed of what it's going to operate at. So if your max speed is in heating on a gas furnace, great, operate it in heating. If your max speed is in cooling, operate it in cooling. All right, pretty simple. Now, when you start this up, before you start balancing, first you want to record the discharge air temperature. This is really important because when you're done, you're going to also record the discharge air temperature, so that way you can make any adjustments for the properties of air, because obviously as the temperature changes, the weight of the air changes. So I'm not going to get into the details on psychrometrics. I just want to make sure you guys are recording this so you can make that adjustment if needed. Also, if you're running it in cooling, you're going to record the percent of relative humidity in the return, okay? Really important. So also, if we're going to be removing moisture, the weight of the air changes, so therefore we need to adjust for that when we're done, okay? So very important there as well. Record it when you start and record it when you finish if you're running it in cooling. And then same thing with static pressures. Measure the static pressure drop across every device when you start and every device when you finish, all right? Because if the weight of the air changes, the pressure also could change. So very important you're walking through those steps. And then of course, total CFM. That should be a no-brainer there, but if you measure total CFM first and the weight of the air changes, the cubic feet per minute could possibly be different when you're done. So make sure you measure that total CFM at the end as well. So any sort of installation issues is not going to be fixed with testing and balancing. There are a few specific that always come up. So automatic controls, all right? You have to make sure that these are calibrated before you do your test and balance. So that means anything like economizers or fresher air makeup, relief dampers, VAV boxes in a variable system, right? Exhaust systems. So, you know, making sure you're pulling the right amount of air out if you're using a negative exhaust system and you're just pulling air out of bathrooms. So if you pull too much, obviously that's going to impact the performance of the home and the performance of your heating and air conditioning systems. Big one on there is HRVs and ERVs, all right? You have to make sure an HRV is pulling in the right amount of air and exhausting the right amount of air. There are adjustments with those dampers. It's typically done by pressure on most residential systems. There are ports to hook up a manometer and make those adjustments. Luckily, most of them are very accurate when it comes to the ECM motor in those settings. There's very minor adjustments that have to be made if you purchase the right size HRV and ERV, all right? Bigger's not always better. It's got to be designed correctly, just like a ducted heating and air conditioning system. Also, there's a lot of new zoning systems that use pressure sensors that are electronic. You know, some of the older ones had more adjustments when they were pneumatic, but some of the new ones, if they're off and you can adjust them, you have to make sure you balance that out. And a lot of those are for bypass dampers and things like that to maintain a certain pressure, okay? So really important, those are calibrated first. And then some of the basics, especially if you're going to go back and test and balance an existing system or recommission a system, you have to make sure that that fan cage alignment is correct in the blower section. This sounds elementary, but you wouldn't, it's unbelievable out there. As soon as some of these become imbalanced, the most amazing things happen, okay? Or if somebody replaced the blower, maybe it's not the right horsepower, who knows? Maybe that cage is slightly off. That is obviously going to impact total volume of air. And testing and balancing a system without fixing this first isn't going to help you, all right? So fix that cage alignment first. Obviously, verify the ECM motor settings. I used to see this all the time because AHRI rates all kinds of combinations of equipment in order to get the most efficient equipment in there for a lot of unitary products. So if you have a furnace with a 3.5 to 5 ton drive, or in this case, this is a 1.5 to 3 ton drive, take a look at what the settings that come as, all right? If they're all off, that is set for low on a 3 ton system. That's how it's shipped from the manufacturer. If I put a 2 ton condenser in with say a 2.5 ton A coil on top of that furnace, I need to set the airflow to match the condenser. So if I don't, I'm gonna have really high airflow, very poor relative humidity, right? Because I'm not gonna be able to remove the moisture, and it's gonna be noisy because the system wasn't designed for 3 tons of air. So very importantly, adjust to our design CFM, and of course in cooling, that's going to match the size of the condenser on those unitary props. So verify that before you start walking through, and you're going to notice it with static pressure. Typically with that, if you have a larger drive than what you need for your coils, static pressures are going to be through the roof before that coil, because it's going to be building up all that pressure, because you're trying to move too much volume of air through this restriction now, because the coil is smaller than what it's designed for the air moving through it. All right, so really important there. Double check these settings, then walk through testing, because if you don't, you're going to be doing it 4, 5, 6 times. It's not good. All right. Obviously, testing and balancing cannot fix your equipment selection. If you did not do the full design process, T&B isn't going to help you. All right. It's not going to be able to also fix undersized ductwork. Now, notice it doesn't say ductwork. Testing and balancing actually could help you with oversized ductwork, which I have seen happen quite often. So if it's oversized, that's what we have dampers for. We can damper it down. It may work. We still could have a velocity problem. If you're not familiar with manual D, don't worry. I provide training for that. You can find that on my website. But really important, know that if it's duct's undersized, don't bother with T&B. It's not going to help you. Of course, access for measurements. You can't test and balance a system if they don't have access to the dampers and access to the equipment. Now, obviously, there's mechanical code and having all this access, but that doesn't mean it's enforced in your municipal. So really important that your technicians and your install team provide this in order to actually test and balance the system afterwards. Obviously, as a service guy at heart, that one used to kill me. All right, control configuration and application. A lot of times people put the most amazing controls in, and really I'm referring to zoning systems. You can't put a zone system on and zone off just a 6-inch run. All right, that can't be one zone in most units. All right, so I got to throw that disclaimer out there, because there are some really small units that you might be able to do that with, but you're not going to be able to test and balance that if you have improper zoning or control configuration or application of that product. All right, so let's talk about the actual testing. When you set up your airflow, obviously your design CFM is what you're targeting. You need to be with a max of 110% of your design CFM. Anything larger than that, when you measure volume of air, you should turn down the fan speed. That does not mean you got the equipment wrong or whatever. It just means when you actually applied the product with all the ductwork attached, all the pressure differences in the rooms and all the setup, we have to turn it down, right? It's okay. Turn that fan speed down to match your design. Never more than 110%. And that is because you don't want more than 10% of duct leakage. Now, this is a number that's typically larger than code in most of your areas. If you have more than 10% of duct leakage, then you're going to have to fix the ductwork first before you can test and balance it. So this is really out there for those existing duct systems. You won't be able to balance that thing if you're losing more than 10% of the supply, obviously. Now, obviously, when you set this up and you're going to start walking through testing and balancing, all of your dampers need to start out 100% open. And don't forget, there are some instances where people put dampers in returns to balance returns. I personally am under the belief that you should just size the return duct correctly. But if you're going to put multiple returns in and you don't size it correctly, that's why people put dampers in there. So verify all of those runs have dampers that are 100% open. Typically, those dampers are located right at the takeoff from your trunk. Now, when you're doing this testing, it could take you at up to 3 passes of testing all of those registers in order to get the balancing correctly. So this is time consuming. The more you do it, the faster you'll get, just like any other tool or process, all right? And there are multiple methods of balancing an air duct system, okay? So we're gonna walk through, I'm just gonna give you a brief overview of some of those. But the key here is no matter which method you use, don't take shortcuts. You've got to balance the entire system. Don't just do the couple largest ones and call it a day, okay? Balance the whole system. All right, so these are the 3 methods of balancing ductwork. The first one everybody thinks is the most time consuming, but it's also the most accurate. It's proportional balancing. And that is the worksheet that's on the screen, the system balancing worksheet on the right-hand side. So basically what you're going to do is you measure total volume of air, and you measure the airflow at all of your registers to make sure. So a lot of people just measure those to make sure you're within 110% of what your total CFM is, right? So that way you know that duct leakage isn't going to be a problem. Then you're going to take the largest 2 design CFM takeoffs and measure those. So the first one you're going to measure, you're going to divide it by your design and get a ratio. You're going to measure the second one, divide it by the design, get a ratio, and start walking through the worksheet in order to make adjustments so you know where the air is going to go. So based on the proportional amount of airflow going to that run, you can make an adjustment, know that the rest is going elsewhere, and you go from largest to smallest when you're measuring and adjusting these. So this at first seems like it's going to take the longest, but it's the most accurate, and you can get it done on the first or second pass typically, if you do the math right, all right? The second method is called the highest diffuser method. So this is a little bit more chance, and a lot of people that do testing and balancing, when you have a really small ducted system, you only have a few takeoffs, they opt for the highest diffuser method, because when you start using the largest volume takeoffs and you just adjust those to the right CFMs, it's going to actually, if you're throttling it down, move that volume of air based on pressure elsewhere. All right, so it's kind of a chance. You're going to take the largest 2, it's going to distribute the remainder CFM back to the other ones. If you designed it correctly, most likely you're going to get that done pretty quick. This is not recommended for an extensive trunk and branch ducted system. Like if you have, let's say 10, 12, 16 takeoffs, you're probably going to want to opt for the proportional balancing. So the highest diffuser method could take you more than 3 passes to get it right, all right? And then the last one actually is used if you have a duct system that you want to balance using pressure. So I'm taking a moment here to explain this correctly, because the branch method can be used where you measure all your volume of air and then you measure static pressure in every branch. And then using there's a fan law to know that based on this pressure and this volume of air, if I want this volume of air, this is the pressure I need to throttle down to. Okay, so you plug it into the fan law, and if you are to get those pressures correct, so you start with the biggest ones and go down the line to the smallest ones, if you get the pressures correct, when you then go back and measure, you should have the correct volume of air at those takeoffs, as long as you have a lot of duct leakage in those runs, right? So those are the 3 methods. They actually are pretty easy, but I'm going to be honest, most residential contractors just don't test and balance their duct systems. And I think a lot of it is because it's not being enforced residentially when you pull a building permit right now, at least here in the Northeast. I would tell you, if you do a commercial space, in order to get occupancy, you're going to have to provide a T&B report. It's the same code, all right? Well, I shouldn't say the same, up to a certain square footage for commercial, but it's only a matter of time. You're going to start requiring testing and balancing, especially in new residential systems or new construction. So really important to avoid big pressure differences in spaces when you close those doors, right? So that's why most people put returns in every bedroom. So that way you don't depressurize hallways or cause combustion appliance zone area issues based on pressure. A lot of that boils down to testing and balancing. So I highly recommend you guys get on board. A lot of tools that are needed, you most likely have in your shop already. Maybe a airflow hood's probably the only thing you have to purchase. If you have any questions, please, as a Patreon member, reach out. If you're not here on this live, once we stop the recording, I'm going to take questions and provide some answers on those. Certainly add it to the Q&A piece on the recorded page afterwards. I'm more than happy to hit you back with an answer, or shoot me a message directly. All right. This is going to become a larger part of residential ducted systems going forward in all of New England, based on the new codes, which would be the 2018 international codes, right? So get on board, ask questions, read the books. Really important, design your systems correctly first, obviously, then you can T&B. All right, so what did you think? Did you like the training on air balancing and testing? If you like this sort of recorded training format, head over to my Patreon page and consider becoming a member today. There are 3 different tiers and something that'll fit the needs of each of you. I can't wait to get back to you guys soon. I'm Chris Moore with HVAC Pro Blog, where we provide advice for residential system design, quality installation, and system diagnosis.